My name is Daniel Kwan and this is Bishop Montgomery High School Math Tutoring Club. We're located in Torrance Boulevard right next to Redondo Beach. This video is continued from 1969 AP Calculus BC Section 1 MCQ. So starting from number 15 today. Number 15 says, if f prime x and g prime x exist and f prime x is greater than g prime x for all real x, the graph of y equal to f of x and graph of y to g of x, and it asks the true statements. And so as you look at the problem, it says, we'll write it bigger. And when you look at the option, it says it intersects exactly once or more than once or less than once or, do not intersect, which is less than one, And they just give us the slope field. You have to know the concept of the prime functions to solve this problem. So, for example, when you look at the graph, just y equal to or fx equal to, it is just a graph. So let me graph f of x, just random graph. I'll just graph here, like 2x plus 2. I'll just go like that. Y equal to. And this one will be, so this is a f of x. Not f prime x, but f of x. And this will be, I'll just go up there, do like that. 1.5 x, because, and plus I'll just go 5. Forgetting to write g of that. So, as you look at it, if it is f prime, then it is the derivative of the function of the graph. So that means if I differentiate this function, and f prime becomes 2, right? Because 2x plus 2, and for g prime x, if I differentiate this, g prime x will equal to 1/2, right? Equal to f prime. So this graph, we have proven that this graph's f prime is greater than g prime x. And this is another concept that if one graph has a greater slope, it grows faster. That means it will intersect once, exactly once, no more than once, no less than once, which is do not intersect. Because if it does not intersect, that means it is parallel. However, we see that this is not parallel, and also because it's growing faster, you can see it will intersect sometime, right? So, just memorize the concept how when a graph's function, the function's slope, which is primes, are bigger, that means slope is greater, which means it is growing faster, and which means it will intersect only once, exactly once. Number 16. Number 16 says, if y is a function x such that y prime is greater than 0 for all x, and y double prime is less than 0 for all x, which of the following could be the part of the graph y equal to f of x? As you can see, I'm repeating again from the last problem, number 15. While y is just a function, y equal to something is just a function, y prime will show the y function's slope. And y double prime will show the concavity of the original function. So, in the first given statement, it states y prime is greater than 0. That means slope is greater than 0. Also, in other words, positive. That means it is increasing, right? So, as you can see, between A, B, C, D, and E, C and D are both decreasing at some point. While C is decreasing all the time, D is increasing, but when it reaches the positive x-axis, it starts to decrease at some point. So you can cross off C and D. Now the next given statement is y double prime. So y double prime, like I said, is the concavity, concave up or concave down. If the concavity, its number is positive, it will be concave up, looking like this. If it is negative or less than 0, y double prime is less than 0, it will be concave down like that. So, now, because we crossed off C and D, now A, B, and E is the left graph. So, A, A, B, and E. So, how do I do this? Because it says y double prime is less than 0, that means it's concave down because it's negative. So, let's start with A. This is concave up, and the A looks like concave up, so we can cross this off. B. This is concave down, and this looks like concave down. So we can check mark. For E, E is tricky because while it also increases, it also has the positive concavity and negative concavity. So concavity, the point of inflection will be here because it changes the concavity. However, because in the problem it says y double prime is less than 0 for all x, that means the graph has to be all the time concave down. So this has to be wrong. Cross it up because it has concave up here, like it's looking like this, right? So the only answer left is B, which is concave down all the time, like this shape, and the slope is increasing. So the answer for number 16 will be B. Number 17. Number 17 says the graph of y equal to, so I'll write it down, y equal to 5x to the 4th minus x to the 5th has a point of inflection at. So they're looking for POI, point of inflection. So just to make sure, in case FYI, point of inflection is where at that point the curvature of the graph changes, the concavity changes. So for example, while it's concave up, at the point of inflection it will change to concave down. In vice versa, when it is concave down, at that point of inflection it will change to concave up. So let's see. So as you can see, because it's talking about concavity, we have to look for the y double prime. Y is the function, y prime is the slope, and y double prime is the concavity. So I will change to y prime. So this, I have to differentiate this, so goes down 20 like that, minus 5x to the 4th. So this is the differentiation, so solving for point of inflection, sorry. So now because I said curvature or the concavity occurs at y double prime, so I have to differentiate this again. 3 times 20 will be 60x squared minus 20x to the 3rd. I trust you guys to know this already. So we got this, right? So because now we use this and we have to solve for 0 because at the point of inflection, so at the y, I will just draw a random graph for function y. So you see now that while it is concave down until here, it is concave up until here. Now it starts to become concave up from here. So that means at this point, when we look at the y double prime graph, this will touching 0. And if it changes its sign from plus to minus or minus to plus, that means it is the point of inflection. So let's look at it. So because we have to solve for x, because the point of inflection touches the x-axis at the y prime and y double prime graph, let's solve for it. So combine the like terms, 20x squared, I will take it out. So this will become 3, and this will become x. And now, because it's point of inflection, let's solve for 0. So this will be 3, so x will equal to 3, or x will equal to 0. And in the option, it has all the options: 0 for only the x value, 0 and 3 and 4. And before you make the mistake, you have to always check. So the given value, I will put x equal to. So the solved values are 0 and 3. So it will be 0 here and 3 here. So because, like I said, to prove that it is a point of inflection, we have to check if it changes the sign plus to minus or minus to plus. Let's plug in any numbers. So for 0, what's number less than 0? I'll just plug in -1. negative 1 right here, negative 1 right here. So negative 3 minus negative 1 will become the minus times minus plus, so 4. So this part is positive right now, this part is positive, and because for negative 1 it's squared, it's positive again. So this part is positive because positive times positive is positive. Because I think I went so fast, I will do it again. So by plugging in negative 1, this will become 20 because x squared, negative 1, so we got that, times 3 minus 1. This becomes plus, so 20 times 4, positive number, right? So this is positive, so now between 0 and 3. Now between 0 and 3, I'll just plug in 1 now. And let's see, if I do 1 here, it'll be, so if I do 1, 3 times 3 minus 1 will be 2 times, to not confuse you guys, and 20 times 1 squared is 20. So this is still positive. That means we have proved that 0 is not a point of inflection because it's not changing the concavity. Now, for lastly, some number greater than 3. So because sometimes you're lazy to do all things, just plug in extreme numbers so the answer becomes obvious. I'll put like 1 trillion, so positive 1 trillion because it's greater than 3. I'll just plug in positive 1 trillion, obviously negative, and positive 1 trillion obviously positive. So positive times negative, negative, right here. So like this. So because it says positive and negative, 3 is the only point of inflection for number 17, which is option B. Number 18. Number 18 says, if f of x equal to 2 plus, I'll write it down, right up here, f of x equal to 2 plus, absolute value, x minus 3, for all x, then value of derivative f prime x at, so f prime x at x equals to 3 is, so we have to first differentiate this, and don't be scared about differentiating the absolute value. What you have to do is first divide this into 2 equations. 2 minus x plus 3 and 2 plus x minus 3. So we learned this in algebra 1, I think, algebra 2 or algebra 1. So this now, and simplify this, so I'll just write f of x equal to, and f of x equals to 5 minus x equals to minus x, minus 1 plus x. Just write, not confuse you, x minus 1. Now it's our job to differentiate this now because we have to solve for f prime x at 3. X is at 3, so we have to differentiate this. And one answer will become negative 1 and one answer will become positive 1. So f prime x is equal to this, or f prime x is equal to this. If you're unsure about how to graph this and where I got this from, try to graph this first. You know, absolute value, I'll just graph y equal to absolute value x. This looks like that, right? That's why it changes its graph, its function, its slope, slope from negative 1 to positive 1. And now, because it says f prime x at 3, differentiate the value of derivative f prime x at 3, because negative 1 and 1, the answer will be non-existent, which is E. Because as you look at it, x minus 3, so that means because it's inside the function, graph will look like, can you see? Yes. 1, 2, 3, I'll ignore the plus 2, so don't worry. 1, 2, 3, at 3, it has this, right? And because it's at the curve, like at the cone, it doesn't have a slope there, so it is non-existent E. So, as you look at it here, if it is cone, cusp, or any point that changes its slope without any curves like that, if it is cone or cusp, at this point it doesn't have slope. So the value of derivative at this point, value 3, it does not exist. Thank you for watching, and I hope this video was helpful. And this video was from number 15 to 18, so next video will continue from 19. Thank you. If you have any questions, please comment below. And here's the next video.